आज का मेरा टॉपिक सब्स्टिट्यूशन एंड एलिमिनेशन रिएक्शंस ऑफ अल्काइल हलाइड्स। अल्काइल हलाइड्स के सब्स्टिट्यूशन और एलिमिनेशन रिएक्शंस। Organic compounds with an electronegative atom or an electron withdrawing group bonded to a sp3 carbon undergo substitution or elimination reaction। वो ऑर्गेनिक कंपाउंड जिनमें एक इलेक्ट्रोनेगेटिव एटम होता है या फिर एक इलेक्ट्रॉन विड्रॉइंग ग्रुप होता है जो कि sp3 हाइब्रिडाइज्ड कार्बन एटम के साथ बॉन्डेड होता है, वो सब्स्टिट्यूशन या फिर एलिमिनेशन रिएक्शन देता है। हलाइड्स आयंस आर गुड लिविंग ग्रुप। हलाइड्स आयंस जो हैं वो लिविंग ग्रुप हैं, अच्छे लिविंग ग्रुप हैं। सब्स्टिट्यूशन रिएक्शन ऑन दीज कंपाउंड्स आर very easy and are used to get a wide variety of compounds. Rx plus Y negative, substitution Ry plus X negative, elimination R plus X plus Hy, alkyl fluoride, alkyl chloride, alkyl bromide, alkyl iodide. Alkyl halides in nature synthesized by red algae. Red algae is shown in the picture. Synthesized by sea hair, एक sea hair जो है वो दिखाया गया है यहाँ पे इस तस्वीर में। Alkyl halides in nature, several marine organisms including sponges, coral and algae synthesize organohalides, halogen containing organic compounds that they use to deter predators. For example, red algae synthesize a toxic that keeps predators from eating them. One predator, however, that is not deterred is a mollusk called a sea hare. After consuming red algae, a sea hare converts the original organohalide into a structurally similar compound it uses for its own defense. Unlike other mollusks, a sea hare does not have a spell. Its method of defense is to surround itself with a slimy material that contains the organohalide, hereby protecting itself from carnivorous fish. Substitution reaction with halides. If concentration of reaction 1 is doubled, the rate of reaction is doubled. If concentration of 1 and 2 is doubled, the rate of reaction is quarts plus. If concentration of 2 is doubled, the rate of reaction is doubled. Bromoethane and gives us product is methanol. Substitution reaction with halides, bromoethane plus OH negative hydroxyl ion and product is methanol plus bromide ion. Rate law. Rate is equal to K concentration of bromoethane and concentration of hydroxide ion. This reaction an example of a SN2 reaction. S stands for substitution, N stands for nucleophilic, 2 stands for bimolecular. Mechanism of SN2 reaction. The rate of reaction depends on the concentration of both reactants. जो rate of reaction है वो दोनों reactants की concentration पे depend करता है. When the hydrogen of bromoethane are replaced with methyl group, the reaction rate slow down. जब हम हाइड्रोजन जो है ब्रोमोइथेन के उसको रिप्लेस करते हैं मिथाइल ग्रुप के साथ, तो रिएक्शन का जो रेट है, स्पीड है, वो कम हो जाती है. द रिएक्शन ऑफ एन अल्काइल हैलाइड इन विच द हैलोजन इज बॉन्डेड टू एन asymmetric center leads to the formation of only one stereoisomer. Alkyl halide relative rates. 1200 relative rate of the bromide and 40 and 1 and is 0. Mechanism of SN2 reactions. Woods and Ingold proposed the following mechanism. Transition state, increasing the concentration of either of the reactant makes their collision more probable. Mechanism of SN2 reaction. Steric effect, inversion of configuration, activation energy reaction coordinates bromobutane. Factor affecting SN2 reaction, the leaving group, the nucleophile internal for halogen substitution, the strongest the base, the better the nucleophile. SN2 reaction with alkyl halide, an alcohol, a thiol, an ether, a thioether, an amine, an alkyne, a nitrile. Substitution reaction with halides, 1 bromo, 1,1-dimethyl ethane, 1,1-dimethyl ethanol. If the concentration of 1 is doubled, the rate of the reaction is doubled. Rate of reaction is equal to K concentration of the reactant. This reaction is example of a SN1 reaction. S stand for substitution, N stand for nucleophilic, 1 stand for unimolecular. If concentration of 2 is doubled, the rate of reaction is not doubled. यानी कि अगर हम दूसरा हमारे पास रिएक्टेंट है पानी, उसकी कंसंट्रेशन हम डबल कर देते हैं तो ये रिएक्शन का रेट जो है वो डबल नहीं होता. ये यूनिमॉलिक्यूलर है क्योंकि रेट ऑफ रिएक्शन सिर्फ एक रिएक्टेंट पे डिपेंड कर रहा है, वो है अल्काइल हलाइड. Mechanism of SN1 reaction. The rate of reaction depends on the concentration of the alkyl halide only. When the methyl group of 1 bromo 1,1-dimethyl ethane are replaced with hydrogens, the reaction rates slow down. The reaction of an alkyl halide in which the halogen is bonded to an asymmetric center leads to the formation of 2 stereoisomers. A small rate is actually observed as a result of a SN2. Alkyl halide and their relative rate. Mechanism of SN1 reactions. Nucleophile attack the carbon cation. Carbocation. C. Carbon bromide bond breaks. Proton dissociation. Mechanism of SN1 reaction. Rate determining step. Carbocation intermediate. Mechanism of SN1 reaction. Inverted configuration relative the alkyl halide. Same configuration as the alkyl halide. Factor affecting SN1 reaction. 2 factors affect the rate of a SN1 reaction. The ease with which the leaving group dissociate from the carbon, the solubility of the carbocation. The more the substituted the carbon cation is, the more stable it is and therefore the easier it is to form. As in the case of SN2, the weaker base is the leaving group, the less tightly it is bonded to the carbon and the easier it is to break the bond. The activity of the nucleophile has no effect on the rate of a SN1 reaction. Comparison of SN1 SN2 reaction. SN1 a 2-step mechanism, SN2 a 1-step mechanism. A unimolecular rate determining step, a bimolecular rate determining step. Products have both retained and inverted configuration relative to the reactant. Product has inverted configuration relative to the reactant. Reactivity order of methyl. Elimination reactions. 1 bromo 1,1-dimethyl ethane 2 methyl propane. Rate of reaction is equal to rate constant concentration of the reactants This reaction is an example of a E2 reaction. E stands for elimination, 2 stands for bimolecular. The E2 reaction, a proton is removed, bromine ion is eliminated. The mechanism shows that an E2 reaction is a one-step reaction. Elimination reactions: 1 bromo, 1,1-dimethyl ethane, 2 methyl propene. If the concentration of 1 is doubled, the rate of the reaction is doubled. If the concentration of the reactant 2 is doubled, the rate of the reaction is not doubled. 2 methyl propene rate law, rate is equal to concentration of alkyl halide, only one reactant. This reaction is an example of an E1 reaction. E stands for elimination, 1 stands for unimolecular. The E1 reaction, the alkyl halide associate forming a carbocation. The mechanism shows that an E1 reaction is a two-step reaction. The base removes a proton. Products of elimination reaction: the most stable alkene is the major product of the reaction for both E1 and E2 reaction. For both E1 and E2 reactions, tertiary alkyl halides are the most relative and primary alkyl halide are the least reactive. The greater the number of alkyl substituents, the more stable is the alkene. Competition between SN2 E2 and SN1 E1. SN2 and E2 are favored by a high concentration of a good nucleophile strong base. SN1 and E1 are favored by poor nucleophile weak base because a poor nucleophile weak base disfavors SN2 and E2 reactions. Competition between substitution and elimination SN2 E2 conditions in a SN2 reaction in a E2 reactions. Competition between substitution and elimination SN1 E1 conditions. An alkyl halide that react under SN1 E1 condition will give both substitution and elimination products 50-50%. Summary: alkyl halide undergo two kinds of nucleophilic substitutions, SN1 and SN2, and two kinds of elimination, E1 and E2. SN2 and E2 are bimolecular one-step reaction. SN1 and E1 are unimolecular two-step reaction. SN1 leads to mixture of stereoisomers. SN2 inverts the configuration and asymmetric carbon. The major product of elimination is the most stable alkene. SN2 E2 are favored by strong nucleophile strong base. SN2 reactions are favored by primary alkyl halide. E2 reactions are favored by tertiary alkyl halide.